electrons moving at high speed are slowed down rapidly by striking a target. So, if we have an electron, suppose it is an electron, and when we apply a voltage, for example, we have to, sorry, it does not work. Okay, when we have a charged particle and when we move it in a direction and when we stopped it, stopped what? Stopped charged particle. Usually we mean electrons. When we stopped and when we slowed down the charged particle by target. For example, the electron strike a metal, for example, a tungsten, X-ray is produced. We speak about that, how X-ray is produced. Of course, only 1%. I want to, okay. Of course, only 1% of energy of electrons is coming from X-ray. The remainder being dissipated, being wasted as substantial heating of target. I want again to write for you. For example, it is an electron. Okay. When we apply a voltage on the electron by using of two electrodes, a negative electrode and a positive electrode, there is a voltage difference here. For example, 50, it is an example, 50 kilovolts. So, electron will repelled from the negative electrode and will be absorbed to the opposite or positive electrode. Finally, the electron strikes to the target. For example, it is a metal, and usually this metal is a tungsten, is a high density metal. When electron strike to the target, X-ray will be produced. It is an electron. You know, in physics, if we want to calculate the energy of this electron, it is really, and it is pretty easy. The energy of electron here, when it's absorbed toward to the right electrode, will be this voltage, multiplied by the charge of electron. The charge of electron is the energy of electron. And we say that a small part of this energy will be converted to X-ray, and most of its energy will be converted to heat. And of course it is not good. We want this part of this energy. So again, we apply a voltage to electron. Electron moves toward the right, moves toward the positive electrode. Electron strikes the positive electrode. Energy of electron, which is calculated by this formula, will be converted to two parts. First part will be an electromagnetic radiation, which its name is X-ray, and most of this energy is dissipated, is wasted as a heat, as warmness. The X-ray, please notice to my voice, please notice to my sentences. It is very important. This is a device named X-ray tube or X-ray lamp. They are same. X-ray lamp. An X-ray lamp, I mean here, this part, is consisted of some parts. First of all, a glass envelope, a glass envelope, a glass cover. It is this. Then, please notice to this part. Then, we need electron. I taught you that electron must be produced and then slowed down, stopped, and finally we have X-ray. For producing X-ray, please listen to me. For producing X-ray, we use a filament. A filament is a spring. A filament made of tungsten, which is heated by a little current. It is a current flowing to this filament. It is filament, okay? And it is the electrical current. When this filament is heated, electrons are released. Electrons are released, are produced. Now we have electrons. This part of X-ray tube is named the cathode. So if I ask you what is a cathode, you answer me that cathode is a part of X-ray tube which produce electron. How it produce? It is a filament. It is a spring made of a heavy metal. This metal is tungsten. This filament is heated by a little current. It is a current going to and coming out. And then this filament is heated and produce electron. Sorry, I want to turn off the heater. Okay. This part of the X-ray tube, is cathode. Why it is cathode? Because it is connected to the negative voltage. It is connected to negative voltage. So we have a closed circuit. Left side is connected to positive voltage and the right side is connected to negative voltage. Okay. At the opposite side here, we have another part. This part is named anode. Why anode? Because it is connected to positive voltage. Anode is composed of, again, a heavy material. Again, the metal is tungsten. Same as here. It is a spring. It is a filament of tungsten. It is a block of tungsten. Of course, this block is embedded is ended or is covered by another metal, for example a copper. Copper can easily convey the heat, convey the current. So when the voltage difference is applied between cathode and anode, electron moves from right to left. Then electron strikes the anode and finally X-ray will be produced in this direction. Okay. So if again I ask you, please write the components or the parts of X-ray tube. First, a glass envelope. It is a lamp. It is a tube. Second, the cathode. The cathode is a metal filament, is a metal spring consisted of tungsten. It is heated, it is warmed by a little current to produce electron, to release electron. Third, we have anode. Anode again is a block of tungsten which is embedded in the block of the copper or similar metals. And four, we need a battery. We need a voltage source. Of course, the voltage that we use for producing X-ray is between 15 kilovolt, not volt, 15 kilovolt to 150 kilovolt normally. Then electron moves from cathode to anode and electrons are slowed down, are stopped, and X-ray will be produced. Of course, we have some little parts. For example, a focusing cup. This cup, which is connected to a negative voltage, focus electrons to the left side. Another part is a window. Window is the exit part of the X-ray tube for sending X-ray toward out. And it is finished. Of course, the X-ray lamp, the X-ray tube is covered, is protected by a lid casing or a lid coverage. This coverage or this protecting casing is used for preventing the X-ray come out from the other part except of window. So for protecting the other personnels maybe here. Okay, we only need X-ray in this direction. Only in this direction. Between the lid casing and the X-ray tube, we have oil. This oil helps the system to send out a lot of heat that is produced here. So it is for cooling the X-ray lamp. Okay? Is there any question, students? Doctor, this electron does not launch a photon. They call it an X-ray. No. The photon, if you mean the photon or the X-ray photons, is produced when the electron is slowed down. Only this. There is no an interaction between electron and photons. If you think my answer is okay, please say me. Please let me know. Muhammad Ala. Muhammad Ala, okay. Okay. So again, Muhammad Ala, listen to me. Doctor, could you send the PDF file on the email? PDF file about what? Please say me my colleague, Mrs. Haydari, send you this files for you, I think. Yes. This week we send you the slides of the X-ray. No, don't worry. There is no problem. Okay. Yes, it is my work. You should read the course. Any other question? Can I continue? Okay, Abdullah, can I continue? Okay. So it is the component of the X-ray tube. Okay, now we want to speak what happens in the anode, how X-ray is produced, why, this is the question, why the electron are slowed down, why the electron when stopped the X-ray will be produced, why? There is two mechanisms for producing X-ray. Please remember that the electron coming from the cathode now are entering or striking the block of anode, the block of positive pole of lamp. When electrons, there is two events for electron. First, when electron, it is the atoms of anode, the atoms of tungsten. I said you the tungsten is a metal with a high density and with a high atomic number. It is the nucleus of the tungsten, and there are electron shells or electron layers around the nucleus of atom. Okay, there are these. When electrons reach the nucleus of anode atom, which its polarity is positive, the path of the electron will be changed. The energy of electron will be reduced. The difference between energy of electron before deviation and after deviation will be converted to X-ray. The electron is slowed down here, which results in, this is the German name of X-ray. An electron is slowed down, which results in Bremse-Strahlen radiation. Bremse-Strahlen radiation is X-ray. But which X-ray? The X-ray that is produced by slowing down electrons around the nucleus of the anode atom. Okay, this X-ray is Bremse-Strahlen radiation, or its another name in English is breaking ray. Breaking ray. Breaking in Arabic, I think, means توقف. توقف. Yes, because electrons here are stopped. Electrons changes their direction. Why? Because electron is negative. Nucleus is positive itself. And the difference of energy before the slowing down and after slowing down will be transferred to the X-ray. The second method of producing X-ray is this. When the electron coming from cathode strike not to the nucleus, strike to an inner electron. Strike to an inner electron. This electron This is a striking electron, and this is the ejected electron. And electron from upper layer dropped to this empty space. No, we don't have any electron. Why? Because this coming electron push out, ejected out this electron towards outside. No, we have a hole here. We have an empty space here. This empty space is filled by upper electron. And you know, when an electron from upper layer comes to a lower layer, comes to a lower shell, a photon is produced. This photon is again X-ray. But this X-ray is not Bremsstrahlung radiation. This X-ray is a linear spectrum X-ray. But this X-ray is a continuous spectrum X-ray. So an inner electron is removed, causing ionization. This atom now is ionized. What does mean ionization? Ionization means when an atom loses its electron and then becomes positives. And finally, an X-ray is emitted. How? Because here we don't have electron, and this empty space is filled by outer electron to this layer. I want to write for you a thing. Suppose it is a layer, and suppose it is an upper layer. If binding, you must know what is binding energy. Every layer, every shell of electron around the nucleus has a binding energy. When we comes out from the nucleus, the binding energy will be reduced. Okay. If the binding energy of electron of this layer is E1, and binding energy of this layer is E2, and an electrons comes from E2 layer to E1 layer, okay, a photon is emitted. The energy of this photon, h nu, will be equal to E2 minus E1. Okay, this is this type of X-ray. First type of X-ray was produced when it is nucleus of the target atom. It is coming electron. It has a positive charge. This electron has negative charge, and the direction of electron will be changed. Energy before deviation is E1. Energy after deviation will be E2. E1 minus E2 a photon is produced. H, no. Okay. So if I ask you, please say me how many type of X-ray we have, you say me that we have two type of X-ray. First, an X-ray with continuous spectrum. Continuous of spectrum, it means that we have a bundle, we have a package of X-ray photon of electromagnetic radiation with continuous spreading of energy with no interruption. How this type of this X-ray is produced? When electron reach the nucleus of the target and the direction of electron is changed and X-ray is produced. Finished. 2. When coming electron from cathode strike to an inner electron, the electron ejected out, the electron removed, the atom ionized, and the empty space is filled by upper electron. Transition of electron from upper layer to down layer is equal to production of X-ray. And X-ray with linear spectrum, not a spectrum of X radiation. Bremse-Strahlung radiation. You know what is Bremse-Strahlung radiation if I ask you in my examination. Results in a continuous spectrum. There is a short wavelength limit to the spectrum, which is when all energy of incident electrons is to an X-ray photon. Yes, when electron directly strike to the nucleus of the target atom, all of energy of electron will be converted to X-ray. I draw for you. This is when electron directly strike to the nucleus atom and all of energy is converted to X-ray. It is the most powerful, the most energetic X-ray which is produced with the less wavelengths. You know that when wavelengths increase, the energy decrease, and when the wavelength is decreased, energy will be increased. So, energy maximum of electrons, you know, is equals to V is charge of electron, and V0 is the peak voltage of applied voltage. I say you that for producing, please notice to me, this is questions, I say you the question of my examination. So it is very simple. If the voltage between cathode and anode, the maximum voltage is V0, and the charge of electron moving from cathode to anode is E. Okay. So energy, the maximum energy is, and also the maximum energy of X-ray that will be produced in the future also will be this. So energy max of electrons is equal to E0. What is E? Charge of electron. What is V0? Peak value of applied voltage. So if all of this energy of electrons converted to X-ray, it will be energy max of photons. And you know that this formula, please write this formula. Energy of photons equals to h nu. What is h? It is Max Planck constant. What is nu? It is frequency. We can also, this formula in this form, h multiplied by c divided by wavelengths. It is a speed of light at space. It is lambda wavelengths. If is maximum, lambda will be minimum. It is very easy. Okay, you understand? So we write Emax equals to Hc divided by lambda minimum, V0. Energy of electron. So lambda minimum will be equals to Hc divided by EV0. If we write the Planck constant, if we write velocity of light in the space, finally we reach to this simple formula for calculating of lambda minimum. 1.24 multiplied by 10 power to 9x divided by peak voltage. It is this. All of this part converted to this number. Because we know what is Planck constant, what is velocity of light, what is the charge of electron, they are constant number. They are not changed. So they will be converted to this simple number, and only we need the maximum voltage, the peak voltage. So, for example, I ask you the voltage between anode and cathode, for example, is 100,000 volts. Okay. What is lambda minimum? You write 1.24 10 power to 9 6, and finally write 1.24 by 10 to power minus 11 meter. It is the range of wavelengths we have for X-ray. It was an example. In my examination, I give you another voltage, and you can easily calculate lambda minimum. Okay. So again, we want to calculate, to compute energy maximum of X-ray that is produced in an X-ray lamp, in an X-ray tube. Okay, we know that all of energy of electron that is computed by this formula can be converted to X-ray. Okay, it can be easily calculated. On the other hand, we know that energy of photon, energy of X-ray is equal to Hc divided by wavelengths. If this is energy maximum, lambda will be minimum at wavelengths. So lambda minimum equals to Hc divided by EV0. And then by placing the right number, we find this important formula. So you must put in your mind this formula. Here you see the spectrum of X-ray. It is a profile. Please notice and please learn this part. It is a profile. The x-axis is wavelengths. You know what is the wavelengths. And the y-axis or vertical axis is relative intensity. Relative intensity. This spectrum has two parts. First part is this, a continuous spectrum. And the second part are this vertical line. This vertical line. This vertical line are linear spectrum. And sorry, I must connect the laptop to the electrical source. Okay, sorry. So, if I ask you, how is the spectrum of X-ray, you say to me, you answer to me, we have two types of X-ray. First type of X-ray is continuous or Bremsstrahlung X-ray, which is produced when electrons are slowed down around the nucleus of anode, or when the electron is directly strike the atom. It is the minimum lambda. It is the maximum energy when electrons strike directly to the nucleus. It is produced here. And then we have a peak of intensity and down of intensity for continuous X-ray. Also, we have linear spectrum. How linear spectrum is produced? When the coming electron strike to inner electron of target, electron removed, and upper layer electrons falls, comes to fill the empty layer, and for every transition, every fall of electron, we have a separate photon. So we have linear spectrum. Okay? What is this? So continuous spectrum and linear spectrum. What is K line? It is the electrons. I show you. It is K layer. It is L layer, M layer, N layer. Okay. K line or K X-ray are X-ray when the upper electron falls in the K layer. What is L layer? L line X-ray, L electron is removed and upper electron comes to the L layer. Every layer has its own linear spectrum. I hope you understand. It is L line. It is K line. Of course, the K line are more important. Why? Because they have more energy relative to the upper layer electrons. Now we are speaking about line spectrum. Another name of line spectrum or second type of X-ray is characteristic X-ray. اختصاصی, I think in the Arabic will be اختصاصی. اشعه X اختصاصی. Ionizing result in characteristic or line spectrum. Again, electrons from cathode strike to an inner electron. Is this electron push out, will be removed, and here the electron from upper layer falls, and here we have this X-ray. It is X-ray with line spectrum, not continuous spectrum. Each line is a result of the change in the energy of a particular electron in an atom of a target. The lines are named according to the shell in which the electron terminates. Please notice again, the lines are named according to the shell in which electron terminates. I want to show you for you again. It is nucleus of atoms. It is K shell. It is L shell. And they are the outer shells. K, L. When we have an empty space here, when electron from upper layer comes to L, comes to K shell, X-rays are named K-line X-ray. According to the shell in which electrons terminate. Here means K. When we have a empty in the L line, so the electron comes from the upper layer to the L shell. This linear X-ray, this X-ray are named L line. Okay, it is very simple. Those with the shortest wavelengths which result from a transition to the innermost here, innermost K shell are K lines. So if I ask you K line has more energy or L line, you answer me K line. Why K line? Because K line is near to nucleus. It has the most binding energy, the higher binding energy. So difference between this line to the upper line is more. And then the X-ray which will be produced has more energy than the other line. It is very simple. In terms of the quality of X-ray, the effects of X radiation, depends both on the intensity energy per unit area. For example, meter square, centimeter square, and a spectral speed. It is important for us, for doctors, for physicians, that when X-ray strikes to our body, how it transfers its energy. It depends to two important factors. First, intensity, and then spectral speed. And you know what I mean. You know what is the speed, spectral speed. We had two spectral speed. The first, continuous spectral speed, and then linear spectral speed. Spectral speed determines how penetrating the radiation is. It means quality. It is better I show for you. Here you see another form of a spectrum. If I ask you what is this, you say me continuous spectrum. Continuous spectrum. You see that here there are some number, 200 kVp, 100 kVp, and 50 kVp. kVp is the peak voltage between anode and cathode. And if I ask you, for example here, what is the maximum energy of electrons coming from cathode to anode, here you say to me, oh, it is very simple. 200 kilovolts by charge of electrons, because we know that W, or energy, is result of multiplying of voltage by charge of electron, or charge of the coulomb. So we say that energy of electron here is 200 kilo electron volt. It is a unit of energy. We know in physics that if we have two electrodes, a negative electrode and a positive electrode, and we have an electron here, this electron is repelled from negative and absorbed by the positive negative, moving left to right. If the voltage between the minus and the plus voltage is volt, we say that 1 electron volt is equal to of energy of this. So if the voltage between anode and cathode is 200 kilovolt, so it is very simple that the energy of electron here is 200 kilo electron volt. So here the voltage, the energy of electron is this. And if I ask you what is the maximum of energy of X-ray, you again see is this, 200 kilo electron volt. So when the voltage is increased, for example, 50 kilovolt, and then 100 kilovolt, and then 200 kilovolt, the continuous spectrum moves towards right. By increasing the voltage between, please notice to me, by increasing the voltage between cathode and anode, the energy of electron is increased, and then the energy of X-ray will be increased. What is the maximum of X-ray? You say that the same of energy of electrons. That's moving from cathode to anode. Here, in the lower picture, here you see that the kilovoltage in the lower part, in the upper part, the kilovoltage are the same. But the current of lamp is increased. That I explain for you in the next session. Again, I want to finish this slide and to finish my class today. A spectral spread determines how penetrating, how powerful radiation is. This is the quality. Quality means kayfiyat, not kamiyat. Kayfiyat of X-ray. Half value layer, we have index, we have a shakhs for describing the energy or describing the quality of X-ray. It is this, half value layer, the thickness of the material to reduce the intensity to a half. For example, I say you half value layer of an X-ray is, it is an example, is 2 millimeter aluminum. I'm describing this. I mean that a layer of aluminum with thickness of 2 millimeter, if I put in front of an X-ray, it reduces its intensity to half. Okay, we say that half value layer, HVL, of this X-ray is 2 millimeter aluminum. Another example, we say that I have another X-ray with an HVL or half value layer of 4 millimeter of aluminum. That if I put in front of X-ray beam, it reduces its intensity to half. 4 millimeter aluminum. So we understand that this X-ray is more powerful than this X-ray. Quality of this X-ray is more than this X-ray. Quality of X-ray 2 is more than X-ray 1. Wow, how we explain the quality of X-ray? By half value layer, the thickness of material to reduce the intensity to half. Okay, now I want to finish because I think you may be tired. If you have any question, please ask me. Muhammad Allah write in Arabic and I don't understand what he says. Do you understand this course today? Was it what good? Are you tired today? It was good. Alhamdulillah, Alhamdulillah. I hope you understand and learn this course. The light and eye was also very important for me, and in the continue we speak about the X-ray. Doctor, will be exam be I don't MCQ? Yes, my form of examination is MCQ. If you mean that multiple choice, yes. Do you like multiple choice? Do you like multiple choice? Okay, I think the multiple choice is the good form of examination. Khuda Hafiz. Until the next week, have a good and take care of yourself. Bye.